Today we're going to talk about solving quadratic equations by graphing. We've solved by factoring a little bit before, and now we're going to solve by graphing. So first we're just going to overview what this might mean. So here we've got the line y equals 3x. Notice that it has a y-intercept of 0 and has a slope of 3, up 3 over 1, up 3 over 1. That stuff we already know. We want to know, when does 3x equal 6? So notice that in the place of the y we've got a 6. When do we reach 6? Well, here's 6, and if we come down, we can see that's where x equals 2. X equals 2 is the solution to the equation. And in fact, if we plug in 2, when do we get 3 times 2 is in fact equal to 6, so that's work. How do we see the solution on the graph? The point 2, 6 is on the line. Okay? All right, so now let's look at this equation. 3x minus 6 equals 0. Now we've graphed 3x minus 6. We started at negative 6 here. And up 3 over 1, up 3 over 1. What's the solution to this equation? In other words, when is 3x minus 6 equal to 0? When is the y value 0? Well, that's right here. It's when x equals 2. And for the same reason, 2, 0 is on the graph. Okay, this next part is, how is the graph solution to number 2 related to number 1? Well, it's the same x value in our solution. So that's one thing we see. Same x value. And the graph is actually just slid down from here to here, right? Here we've got y equals 3x. Here we've got y equals 3x minus 6. So we'll say the graph for number 2 is translated down. So if we wanted to know where 3x equals 6, we could figure out where 3x minus 6 equals 0, or we could just figure out where 3x equals 6. All right, let's look at this next part here. Now we've got x squared minus 4. Here's the graph of x squared minus 4. How can we see the solutions to this equation? We want to know where x squared minus 4 equals negative 3. So let's find negative 3. 1, 2, 3. Here's negative 3. And I can see there are two places, two solutions. So the solutions are x equals 1 and x equals negative 1. How do we see those solutions on the graph? Well, 1, negative 3, and negative 1, negative 3 are on the graph. Okay. Now we're going to solve a similar thing, but we've moved the graph up 3. And now we want to know where's x squared minus 1 equals 0. It's these two places here. So again, it's x equals negative 1 and x equals 1. Negative 1, 0. And 1, 0 on the graph. How are they related? Again, it's the same. Same x value. Graph is translated up. Okay. So we're going to apply this to do some solutions. So this says, based on what you've observed on the front page, why do you think we most often solve equations of this form, equaling 0, rather than this form? So we can always, the answer is that setting things equal to 0 is a nice way to deal with things. Seeing where we cross the y-axis is a question we might rather ask than where do we hit this particular y value. Okay? So you're going to see a lot of these equal to zeros. So here we've got this graph. Where is this equal to 0? We've got these 2 points, and it's going to be x equals, x equals. So here we've got x equals 1, x equals negative 1. Next one. There's just one solution here, x equals 0. That's the only place where this crosses the y-axis. We've graphed x squared plus 1, and where's that equal to 0? There are no solutions there. Because it's never equal to 0. It never crosses the y-axis at 0. Okay, looking down here, I'm going to do number 8, number 9 with you. You're going to go back and do number 7 by yourself. We've got this graph, y equals 3x squared minus 12, and we want to know where's that equal to 0. I'm going to look at these two y-intercepts, and it looks like 2 and negative 2, so my solutions are x equals 2, x equals negative 2. It's worth plugging that into making sure it works. 2 squared is 4. 3 times 4 minus 12 is, in fact, 0. That works. All right, here I want to know where's x squared minus 4 equal to negative 4. So I'm going to have to look at the negative 4 on this one, right? Not the 0 because it's not set equal to 0. The only place that that works is x equals 0. And if I plug in 0, that actually works. So this one only has one solution. These problems are similar to what we practiced. Down here, it says use square roots. So to do that, we're going to isolate x squared and then take the square root. Okay, let's do number 14 together because we did that one graphing already. I'm going to try to get the x squared all by itself. So I've got 3x squared minus 12 equals 0. I'm going to add 12 to both sides. And now I've got 3x squared equals 12. I'm still isolating that x squared. I want it by itself. So divide by 3. X squared equals 4. So x is going to be the positive square root of 4, or it could be the negative square root of 4, because there's two solutions to this, right? So that's x equals 2, or x equals negative 2. Each one of these is similar. Okay, you're going to have to isolate the x squared, get it to like this point where you've got x squared equals something, then take the square root, remembering to do positive and negative square roots. Back page, we've got factoring practice, right? Go back and watch the factoring video if you need help on that. And we've got graphing practice. Remember axis of symmetry? X equals negative b over 2a. That's our axis of symmetry. And then our vertex is always xy. This is the same as axis of symmetry. And this we plug in to find. Okay, this is in your notes as well. I just wrote you a little reminder there.